This is the Algebra 1 Summer School, Unit 5, Lesson 1, Factoring by a GCF lesson video. All right, so this is our factoring unit. We're going to learn a few different factoring methods. The first method of factoring we will discuss is called the greatest common factor. Okay? The very first step when trying to factor any kind of factoring method, so everything we do this unit, is we're going to try to take out a greatest common factor. We also call greatest common factor a GCF for short. So that's how I'm going to refer to the greatest common factor, is as GCF. All right, the greatest common factor, that is the largest number and exponent that each term of the polynomial has in common. So we're going to start with these first examples here. These are just numbers and terms, and we're going to try to figure out what the greatest common factor is. So in order to do that, I'm going to show you the long way, and then hopefully you'll start to see a pattern, and then we can make it kind of a shortcut. So when I start here with 4 and 8, I'm going to list all the factors of 4. All the factors of 4 are 1 multiplies into 4, 2 multiplies into 4. That's what a factor means, a number that multiplies into something. And 4 multiplies into 4. That's a factor. Now let's find all the factors of 8. Right? Well, it seems that 1 definitely multiplies into 8. So does 2. 4 goes into 8. And 8 goes into 8. Now what a greatest common factor is that we look at that list of numbers and we find the largest one, the greatest one that they both have in common. Well, it looks that both lists have a 4. So 4 is the greatest common factor between 4 and 8. Yes, 1 and 2 are also common, but they're not the greatest common factor. All right, next example here, 60 and 18. We're going to do the same thing. We're going to start by finding the factors of 16, or factors of 60, I'm sorry. So those would be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Wow, there's a lot of factors of 60. When we do the factors of 18, the list will be a little shorter. So factors of 18 would be 1, 2, 3, 6, 9, and 18. Okay, well, let's see. Which of those is the largest factor that goes into both? It seems that 6 is the greatest common factor between 60 and 18. So far, so good. Now let's add in x's. I'm actually going to bring number 3 down below here. We're going to find the greatest common factor for 2x squared and 10x. So let's list the common factors of 2x squared. So 2, the only factors are 1 and 2. X squared is x and x. Same with 10x. So 10x is 1, a 2 goes into it, a 5, a 10, and 1x. Well, when I look at my list, they both have a 2. So let me circle the 2 here. That's the greatest number part, but then I have to look at the variable part. 10x only has 1x, and so does 2x squared. So it turns out that the greatest common factor here is 2 with an x, 2x. They have a 2 and an x in common. All right, last problem way up at the top here, jumping around. 25x to the 4th and 50x cubed. So let's look at the factors of 25x to the 4th. Well, the factors of 25 are 1, 5, and 25. And x to the 4th is 4 x's. 1, 2, 3, 4 different x's. Now if I list out the factors of the other term, 50x to the third, we should be able to see what they have in common. So the factors of 50 are 1, 2, 5, 10, and 25. And x to the third is 3x's. So when I look here to try to find the greatest common factor, the number part is pretty easy. That's 25. And then it appears 50x to the third has 3x's, and there's at least 3x's up at top. So that GCF is 25x cubed. Now that's a good way to find the GCF, is to list out every single factor and then look and observe the greatest. But it takes up a lot of space and it's kind of time consuming. So as we work forward trying to find a GCF from a polynomial, hopefully you can do that method, but hopefully we can start to see the greatest common factors a little bit easier. So let's look here. We have 27y squared and 18y. If you need to, you can list the factors of 27 and 18, or you can recognize that 9 goes into both of them. So let's think about our GCF being 9 for the number, but then both of these also have a y in them, at least one y. So I think my GCF is going to be 9y. Now what I'm going to do is I'm going to divide 9y out of both of these terms. Okay? That's how I'm going to figure out the factored form. Now when I divide 27 by 9, right, I get 3y. And when I get 18y divided by 9y, I get plus 2. Now to get fully factored form, we actually end up taking what's left after I divide and sticking the GCF in front. That's my final, what we call factored form. From factored form, I'm able to get back to the original by distributing 9y to both terms. Okay? But in order to be fully factored, you have to have the GCF out in front of the original. So here are the steps to factoring using a GCF. First is identify the GCF. Take the GCF to the front and write the parentheses, just how I finished my answer up above. Then third, divide each term to figure out what's still left after you factor out the GCF. All right, we have lots and lots of practice here. So stick with me. We'll take a break or pause the video as we need. All right, factor each expression. 8x squared plus 12x. Well, if I know my factors of 8 and 12, I know that 4 goes into both of them. 4 is the largest number that goes into both 8 and 12. And then between x squared and x, there's both 1x between them. So I'm going to write 4x is my GCF. So I have to divide both terms in the expression by 4x in order to figure out what goes left in the parentheses. Well, 8 divided by 4 is 2, and x squared divided by x is x. 12 divided by 4 is 3, positive 3, and x divided by x cancels off. So my final answer is 4x times 2x plus 3. That is the fully factored form. Now you could check this answer by distributing the 4x to both terms. So if I had 4x times 2x, that would give me 8x squared. 4x times 3 is plus 12x. Since that is what I started with, I know that I did my work correctly. All right, let's move on to number 6. 5m cubed minus 35m squared. Well, the GCF here, they both have a 5, so 5 is part of my GCF. And then the exponent, m cubed has 3 m's, and m squared has 2 m's. So they have at most m squared in common. When I divide both terms by 5m squared, I'm able to figure out what goes inside my parentheses. 5m cubed divided by 5m squared is just m, 1m. You could put a 1 there if you wanted to. And negative 35m squared divided by 5m squared is negative 7. So your final answer is 5m squared times m minus 7. All right, this one looks awfully long and confusing, but it's not so bad. the first thing you need to do when you're looking for a GCF is examine the numbers, -4, -8, and 2. Now, they all have a 2 in common, so 2 is part of my GCF. However, because this problem starts with a negative sign, I'm going to make my GCF negative. So really, anytime the first term of a polynomial is negative, you want your GCF to be negative. Now I look at the next thing they all have in common. They all have a squared, a, and a. Well, it looks like I can only pull out one a from each of those. Same with the b's. I have b, b squared, and b. But since only 2 of them have one b, that's all I can pull out. So it looks like my GCF is -2ab. So I'm going to divide every single term by -2ab. Well, let's see. -4 divided by -2 is +2. A squared divided by a is a, and the b's cancel off. Next, -8 divided by -2 is +4. A divided by a cancels, just like the b's cancel. B squared over b is just b. -2 divided by, or +2 divided by -2 is -1. The a's cancel, the b's cancel. So that is your final factored form there. All right, let's look at the next row of problems. 6x squared plus 10x. 6 and 10, they're both even, so they probably have a 2. And it doesn't look like there's anything else that's larger than 2. So I'm going to say 2 and x is my GCF. So if I divide both by 2x, I have 6 divided by 2 is 3. X squared divided by x is x. Then 10x divided by 2x is plus 5. All right, the next one, 3x minus 24. Well, the only thing that goes into 3 is 1 and 3. 24 has lots of factors, but 3 happens to be one of them. So 3 is the greatest common factor. There's not an x on the 24, so there's no x in the GCF this time. So all I have to do is divide both terms by 3. 3x divided by 3 is x. -24 divided by 3 is -8. All right, looking at number 10, 10x squared minus 15x. 10 and 15 both have 5 that go into them, and they both have an x, 1x, x to the first. So I'm going to divide both terms by 5x. When I do that, 10 divided by 5 is 2. X squared divided by x is x. Then, over here, the x's are going to cancel off, so I just have -15 divided by 5, which is -3. So your factored form is 5x times 2x minus 3. All right, as I work through the next 2 rows of problems, if you feel confident, I want you to hit pause and try these few problems by yourself. I will do 3 at a time, so if you need help, go ahead and click play again and then give them a shot. All right, I'm going to do 11 through 13. Hopefully you gave these a shot on your own first. All right, so when I look at this next one, I have 4x squared plus 8x plus 24. 4, 8, and 24. Those all have a 4 that goes into them. So 4 is part of my GCF. Now when I look up above, only the first 2 terms have x's. The 24 does not. So there is no 24 as part of your GCF. So I now divide just every term by my GCF of 4. When I do that, 4x squared divided by 4 is just x squared. 8x divided by 4 is 2x. And 24 divided by 4 is 6. When I go back and look through what's left in the parentheses, there does not appear to be any other GCF that I missed, so I know I did my answer right. I can also check, as we talked about earlier, by distributing the 4 to every term. 4 times x squared is 4x squared. 4 times 2x is plus 8x. And 4 times 6 is 24. If I get the same answer that I started with, I know that I factored correctly. All right, looking at number 12. 6, 8, and 2. They all have a 2 in common, so I'm going to put 2 as part of my GCF. But it appears that every term also has at least one x in common. So 2x is going to be my GCF, and when I divide every term by. So when I divide by 2x, the 6x cubed divided by 2x is 3x squared. Negative 8x squared divided by 2x is minus 4x. Then 2x divided by 2x, it doesn't just disappear. The same number divided by itself is a 1. All right, last one in this row. 10x cubed minus 3y squared. Well, 10 and 3, it's hard to figure out, but let's list them out this time. The factors of 10x squared are 1, 2, 5, and 10, and then x, x, x. The factors of negative 3y would be negative 1, 3, y, and y. There's nothing on that list that looks the same. So what actually is true here is that you cannot factor this. Now what we do when we cannot factor is we say that this is prime. There are no factors of this polynomial. So if something does not factor, write the word prime. Okay, only 3 more, just like before. If you're feeling confident, hit pause and then come back and listen if you need an explanation. So go ahead and hit pause now. All right, hopefully you've tried these 3 on your own. If you need some help, here's the explanation for 14 to 16. I need to look at the 10, the 40, and the 50. They're all multiples of 10. So my GCF is actually going to have a 10 in it. Now I look to see if there's going to be a variable. There's an x squared in the first term, an x in the second, but no x in the third. That means there's going to be no GCF of 10, or no GCF with an x. 10 is my only GCF, so that's what I'm going to divide every term by. So 10x squared divided by 10 is just plain old x squared. Negative 40x divided by 10 is minus 4x. And negative 50 divided by 10 is negative 5. That's your final answer. All right, looking at 15, 8x to the 4th minus 2x squared. Well, the 8 and the 2 both have a 2 in common, so I'm going to have 2 as part of my GCF. Now, x to the 4th is 4 x's, and x squared has 2 x's. That means that these terms, both have at least 2 x's in common, which is where I get the x squared as part of my GCF from. So now I can divide every term up above by 2x squared. When I do that, 8 divided by 2 is 4. 8 to the 4th divided by 8 squared is 8 to the 2nd. Then 2x squared divided by 2x squared gives me a negative 1 to finish out. All right, very last problem on the notes. 8x cubed plus 24x squared minus 32x. 8, 24, and 32 all have an 8 that goes into them. Each of these terms also has an x, just one x. So 8x is part of my GCF. Now I'm going to divide every term by 8x by my GCF. 8x cubed divided by 8x squared. 8x cubed divided by just 8x leaves me x squared. 24x squared divided by 8x leaves me plus 3x. And negative 32 divided by 8x is minus 4. Again, if you want to check your work like we talked about, you could distribute the 8x here and see if you get the original equation. 8x times 8x squared is 8x cubed. 8x times 3x is plus 24x squared. And 8x minus 4 is minus 32x. That is what we started with, so we know we factored correctly. Go ahead, there's a bunch of problems. There's 12 factoring practice problems right below these notes. There are answers on the bottom of the page. There's also a short partial practice video posted on Canvas, as well as a second factor by GCF practice with video also posted on campus.